Would you all agree there's a cylinder in this question? A graduated cylinder. So there it is there. And then, shh, it's up there. Now, diameter of 10 means a radius of 5. Okay, now here's what happens. Every single time, every single minute, I pour 20 centimeters cubed of water. Would that be alright? Now, would you all agree that I'm just going to do a little circle here? Do you see this little circle? What does that represent? It represents water in the shape of a cylinder. Okay, now they're asking how high the level will rise. So I believe they're asking me a H question. Agreed? Now, what do we say the radius of this is? 5. Would you all agree that the volume of that cylinder of water I just drew there, the volume of that cylinder of water is 20 centimeters cubed? What do we replace volume of cylinder with? Pi r squared. Alright, I need you guys to finish this. Alright guys, who got pi times 5 squared times h is 20? And then, would you all agree that's 25 pi? And then, the h is not on its own, so we have to get 20 divided by 25 pi. What's the h value then? Including the pi though. Alright. 20. So, if I move this over anyway, it's 20 divided by 25 pi. And the pi button is shift 7. Shift thing, very informative. In 2, 4. I'm going to call it 0.25256 465. 465. 25465. Now, 0.25465. Now, that's how high I go up in 1 minute. How do I know that? Because we only do 20 centimeters per minute, but it wants me to do. So I'm just going to multiply the answer by 10. 2.4. So 2.55. 10 many decimals? Doesn't say. I'll do 2.55. What it is it's full of oil. Agreed? Everybody it's full of oil? Okay. Now, rectangular oil with dimensions 60 by 100 by 100 as shown has a hole in it and is losing rate of oil at the rate of 3.6 litres per hour. Find the rate at which the oil is falling in centimeters cubed per minute. Alright, now this is a tough question, right? The first thing I'm going to do is I'm going to say that it's 3,600 milliliters. Would everybody be cool with that? Would everybody then be cool with 3,600 centimeters cubed? Because 1 milliliter is a centimeter cubed. Now, would everybody be agreed that when the oil leaves, the oil is almost in the shape of a it's in the shape of a box, isn't it? Do you see this red dotted oil I have here? For me, that's what leaves in an hour. All that comes spewing out the sides. Agreed? So in 1 hour, I lose this much oil. Is that okay? And it's in the shape of a small box. Agreed? Now, the first thing I'm going to ask you is, what's the width of the box? What's the depth of the box? What's the height of the box? If it was 100, I'd lose all the oil. I'm only losing a small part of the oil. Agreed? Would you then agree that the volume of this box that I lose in 1 hour has to equal 3,000? So here's what we're going to do. So what's the volume of a box again? Length by width by. So what's 60 times 100? 6,000h equals 3,600. Now divide 3,600 by 6,000 even. And what you get? 0.6 centimeters. So it drops 0.6 centimeters in 1 hour. Alright. Gonna catch that later, Jay. You're gone for all of it. Alright. Now, water is flowing at a rate of 10 centimeters cubed per second into the cylindrical can of diameter 30 centimeters. Find the rate at which the water is rising. Alright, so for argument's sake, what we're doing is we have a cylinder, agreed? Now, is that cylinder completely full? It's not, right? Happy days. Now, for some reason, I'm going to argue that we're pumping the cylinder from below. Is that okay? So, do you see this little tiny hole? The water is being pumped from below, and what's going to happen is, after 1 second, what happens? Would you all agree? The water rises a high H. And the volume of this water is 10 milliliters or 10 centimeters cubed. The volume of the cylinder of water. And then we go pi r squared H equals 10. So every second we pour in 10 centimeters. And what it's asking is, what's the height that happens after 1 second? No. The volume of water is 10 centimeters. The height isn't 10. So, first of all, what's the radius of our can?
50.
So there you go. You can fill in your formula now. You have pi, you have 15, and you have your h equals 10. And your job is to isolate h on its own. Did you get 225 pi? H equals 10. Get the h on its own. It's 10 divided by 225 pi. And what you get is the h value? 0.01, no, not in terms of pi. Get rid of the pi. 0.014 will do me. 1 4 what? Alright, 141, so to keep it as 1 4. And you're done.